Hey guys, this is Mr. Gucci here with your next help video for the 11.2 worksheet, Warming and Melting Solids. So in the first video, I worked on problems 1 through 6, specifically 1 through 3. All right, now I'm going to look at the next set, which is problems 7, 8, 9, and 10. So in these problems, you are going to be using the second of the two heat energy equations that we talked about, in which you are adding heat energy to something to change its state of matter. Now, this equation is actually a lot simpler than the other ones we've worked with before. Here's the equation, right? The heat energy needed to melt something is equal to the mass of whatever substance you're trying to melt times its special melting value, which we call the heat of fusion. Fusion, by the way, just means to melt together. So again, the energy needed to melt a thing is just equal to its mass times its special heating value to melt it, okay? Every substance has a unique heating value, just like every substance had a different specific heat. You'll notice that there is no change in temperature in this equation right here. There is no delta T, because when you're melting something, its temperature stays the same. It does not change. When you have an ice cube that's just starting to melt, it's 0 degrees Celsius. When you come back to that ice cube a couple hours later and it's almost done melting, guess what? It's 0 degrees Celsius. So this is actually a much, much simpler equation. Okay, so let's take a look at the first problem. How much heat energy would you need to melt 1,402 grams of ice once it has reached its melting point? Okay, so we've got 1,402 grams. That's the mass, okay? So we know the mass, 1,402 grams, all right? The question asked us, how much energy is it going to take? So we're solving for the energy, which means we need still to figure out what is the heat of fusion. What is the special heat you need to melt ice? Well, guess what? I told you that it was ice, and so you can look it up. In fact, I provided it on this worksheet right here. If you scroll over to the specific heats, you'll notice that in this column, I provide to you, and I'm just going to highlight column O, I recommend you do the same, and change the text to black. Bam! This is the special melting temperature of different substances. It's how many joules you need to melt 1 gram. And for ice, it takes 334 joules to melt 1 gram. So it's just 1,402 grams times, let's give this a special color, times 334 joules per gram that you melt. You just multiply them together. All right, so 1,402 times 334. The answer is 468,268. 468,268 joules. That's how much energy it takes to melt 1,402 grams of ice. That's it. So 4680. Let me put that into the homework. Let's see if it checks out. All right. 4, oh God, my memory's terrible. 468,000 joules. Ba-ba! There we go. That's correct. Okay. Let me try another one. Let me try number 9. 389,000 joules of energy could melt what mass of gold? Now, it's talking about melting, so I'm going to use the energy and phase change, the energy of melting equation right here. So here I go again. The energy needed to melt something is equal to its mass times the special melting value, the heat of fusion. So we are given a value in this problem, 389,000 joules. 389,000 joules. Is that the energy, the mass, or the heat of fusion? Well, it's joules, so it is in fact the energy. Okay, so you've been given the energy. 389,000 joules. All right. That's equal to the mass times the special heat melting value. Let's take a look. What else does this problem give us? Oh, you know what? It's asking for what mass of gold. It's asking for what mass of gold. So we're trying to solve what is the mass of gold here that this energy could melt. Well, we need one last thing, of course. We need to figure out what is the specific melting value, the heat of fusion for gold. How much energy does it take to melt a gram of gold? Well, we go to this table right here, and if we just go over to the side, all right, go over to the side here. Gold, got it screwed over a little bit. All these things in here. Gold, 64. 64 is the special melting value for gold. It takes 64 joules to melt a gram of gold. So we're trying to find what is the mass of gold that can be melted with 389,000 joules. Well, we're solving for M. And if it's being multiplied by 64, well, the way we solve for M is we divide both sides by 64. And so the mass that we can, joules per gram, the mass of gold that we can melt with this energy is 389,000 divided by 64. 389,000 divided by 64, and we could melt 6,078 grams of gold. Okay, the mass of gold that we can melt is 6,078 grams. That's how much gold we can melt with that given energy. Let me plug it in. 6,078 grams. Let's see if that works. 6,078 grams. Hey, it's correct. Okay, so we got these problems correct. So use this help video to help you solve problems 7 and 9. Again, all you need are the questions here. You need to show your work either in the work column right here or on a separate sheet. And I ask that you reference the heats of fusion, the special melting heat values for substances on the right side of the page. Make sure you go to column O and change the font color to be more visible, like dark red or dark, something, right? Anyways, guys, that's your video. I hope these two videos together help you take care of this homework. Have a great weekend, guys.